So today on the bench, or I should say next to the bench since it's so big, is my Tektronix 570 vacuum tube curve tracer. I picked this up in July, so a little over 6 months ago, and I've been starting to use it a bit more. It does work well overall, but I noticed an issue with the meter. And what I'm seeing is that the positive DC supply is not reading out correctly on the meter. So for example, if I set this to 300 volts, now keep in mind this supply here is variable, but if the knob is all the way clockwise, that's in its calibrated state, so you should be getting exactly 300 volts on this DC plus terminal. And then I set the meter indication to plus DC, because this can read also negative DC, which is a separate control, or the heater, which is your AC heater. So what I'm going to do is I'm going to set it to 300 volt supply. I'm going to set the DC volts range to 350 so we don't go out of range. And then I'm going to flip the test mode on. And what you'll notice is it's reading about 275, not 300. And that's a problem. But if we look at the Fluke multimeter I have here, let's see if I can see that, it's reading 296, which is much closer to where it should be. Probably within spec. I don't actually know what the spec is on that off the top of my head. And well, let's see, if I move this to 200, meter's reading about 180, but we're seeing 197 on the meter. So this problem isn't as bad in some of the other ranges. Now if I go to the 700 volt scale, which is the bottom one, so our 200 is actually reading a little high. Now if I go to 300, it's about dead on. So that tells me that there's a problem with the range resistors in the meter circuit. So we're going to take a look at the schematic, and then we'll pull this thing apart and see if we can't fix it. So here's the schematic showing the plate sweep section and the meter circuit. We're interested in the meter circuit, which is this area here. So here's our meter. Now on these 570s, there was a few different meters that were used. I know this is this shows 200 microamps. I believe there's a 1 milliamp meter, and there was another one as well. If you're interested in reading about the different variations of the 570, I actually made a donation to the Vintage Tech Museum a few months ago, and they scanned the modification summary document for the 570, which hadn't been available on the internet anywhere prior, which covers all of the changes through the life cycle of the 570. So they talk about the different meters, they talk about the different performance improvements that were made. You know, my machine's a pretty early serial number, one-piece case, but they have all the mods in there that are needed to bring it up to spec of one of the later units if you wanted. So that was pretty cool that they were able to do that. So I suggest checking that out if you're interested in, you know, definitely consider making a donation to the Vintage Tech Museum because it's a really great resource. So anyways, here's our DC volts range switch and its resistors. So we've determined that the 700 volt range seems to be okay. So this 3.5 meg resistor R366 is probably good. The 350 volt range seems to be a bit of a problem since it's reading low. So I suspect that this R365 1.75 meg resistor drifted high. I'm guessing it's a carbon comp. And I'll have to spend some more time playing around in the other ranges. But what I'll probably end up doing is we'll just pull this apart and check all these resistors and see how they've drifted. I did some research already on these resistors, and it doesn't look like there's current production exact replacement resistors, so we're probably going to end up putting a couple resistors in series to get these values and power handling, which I don't recall if they're 1 watt or 2 watt or half watt. We'll look at the parts list here in a second. Okay, so here's the parts list. So we're looking at R360 through R366, and it looks like they're actually half watt resistors, so that's good. That'll be easy to come up with a solution for. And if you look at the schematic again, you'll see that the switch switches directly to each of these resistors. So unlike some things, they're not in series with each other. You don't have to replace all of them. You only have to really replace the problematic one. All right, let's get this taken apart. Okay, well, I'm not going to show taking it apart on camera, getting it out of the case on camera, because it's a huge pain in the butt, since this is the early one-piece case unit. This case should be brown, but whoever owned this before painted it this strange blue color, which is not even close to Tektronix blue. So I want to address that one day, but maybe I'll get it powder-coated. Anyways, to get this out of the case, you basically have to set it up on its side, and there's just 2 flathead screws on the bottom you take out, and then you just slide the unit out of the case. It's pretty easy. It's just a bit of a pain since it's so bulky. And here are the screws that I'm referring to. 1, 2. So now that the screws are out, you can just slide it forward, which is sounds easier than it is. It's kind of a pain. All right, and there it is. So this is what the insides of a early model Tech 570 look like. Let's see if I can move the camera around a bit. You can see the last owner of this actually already did a lot of restoration work. Got a bunch of new WEMA caps and different things. I've replaced a few of the neon bulbs in here already. They're giving me a bit of trouble. And it's even got its original silver solder here in the back. Another thing I've noticed on these is that the fan bushings go bad, but you can get those replaced at McMaster Car. They're just a rubber bushing with a stud on each side. I did it on my 575. And we can see that the previous owner also replaced some electrolytic capacitors. I see some terminal strips down there that he installed and some large modern looking blue caps. So that's nice. Alright, let's see if we can find these resistors. Alright, well that wasn't terribly difficult. They were right where I thought they'd be, right on the range switch here. So that's the DC volts range switch. I can see the black one on the top is the 3.5 meg, the one below that is the 1.75, and they just kind of go through the values. So let's get a meter hooked up to that 1.75 and see what it reads. And it looks like a good time to use the extra long Pomona mini or maxi grabbers, they're called. Now, they discontinued these a while ago, but you can find them on eBay from time to time. They're model 4555, and they're definitely handy because they're like a regular mini grabber end, but they're nice and long. So anyways, let's get in there. So one thing I did was I changed the function to heater mode because I don't want any chance of voltage going across the meter. These meters are fragile, and I'm lucky this one even works, and there's really not much you can replace them with unless you can find a Tektronix 130 LC meter. They use the same meter. There's a couple different models of the 130 though, so this would be the early one with the brown case. And I'm not sure if I can do this with one hand, but I'll try. So let's hook onto our 1.75 megohm resistor and on the ground here. And it's reading 1.94, so I have a feeling that's related. And let's check the 3.5 meg just for the heck of it. I think that one should be about okay. And that is a lot closer. And see if we can check some of the other ones. Let me set this down and grab the schematic so I can read the values. Okay, so the next one down should be 700 and then 350. Let's see if I can get to those from this side. So 700K, we're at 728K. Might want to replace that one as well. And let's see the 350. 350 is good. And I think if I flip this over and go to the other side, I should be able to get the rest. So let me write these values down, and I'll be right back when I flip this over. And while I have it on this side, here's a look at the bottom of the 570. Alright, so here's what I got. The 7 volt range is a 34K resistor, and it's 34.1 is what it read, so that one's good. The R361 for the 14 volt range is a 69K resistor. That was spot on, so we're not going to replace that. R362 for the 35 volt range is 174K. It measured 175.6, and 1% acceptable range is 172.2 to 175.7. So that one's creeping up towards the high end. I might replace it if I have a good replacement in stock. The 70 volt range is R363, which is a 349K. That one measured spot on, so we're going to leave that. And then the 140 volt range is the R364 700K, measured 728. The acceptable range for the 1% tolerance is 693 to 707, so that's got to go. R365 is a 1.75 meg, read 1.94. That's for the 350 volt range. It's the one I have the most problems with since I use it the most. And acceptable range is 1.73 to 1.77. So that's our root cause right there. So that's got to go. And the 3.5 meg resistor, it measured 3.54. It's just out of range. We'll see if we can find a replacement for that, but it's not the end of the world if it. I can't, because I don't really use that range that much anyways. All right, let's see what I can find. I did a parametric search at DigiKey for that 1.75 meg resistor. That's not a standard value these days, so the only thing they had in stock, and I basically said anything between 1.73 and 1.77, was a 1.74 meg. So I could maybe do that. Those are 1%. I would have to buy a bunch of them and try to find one on the high side, but I'd prefer to have a perfect 1.75 if I can. Okay, so I've been poking around in my stash looking for some resistor combinations to at least replace that 700K for the 140 volt range and the 1.75 meg for the 350 volt range. I looked at DigiKey and Mauser, and there aren't any readily available good replacement swaps for the most part for those that are in stock. So here's what I came up with. So for the 1.75 meg, I've got actually these are pretty cool resistors. It's a Texas Instruments RN65G 1.35 megohm glass resistor, and I'm going to put that in series with a RN60C 392K resistor, and I'll show you in the meter what those measure. So, and I'll measure them again once I solder them together. Make sure it's not too far off, and it's measuring 1.744. So, our range was 1.73 to 1.77, so that's pretty much the best I think I'm going to get. And then for the 140 volt range, which is a 700K resistor, I've got two resistors here. I've got a RN60D 536K and a RN60D 162K. So let's get those in there and I'll show you what those measure. And that's measuring 699.7K, so that's about perfect for that. So I'm going to get these soldered together, check them again, and then we'll see about getting them installed and testing it out. Alright, so I got the new resistors installed. They measured the same after I soldered them together, so I was happy with that. And I took these tubes out right here, and I was able to get in there with a soldering iron. Luckily they didn't wrap the leads around the posts or anything, they just stuck them through and soldered them, so I was able to just use a pair of long, pliers like these 777s and heat them up and pull them out. I kind of shaped the new ones like a V so they could point towards the inside so there's nothing to hit outside. So yeah, I only replaced the 1.75 meg and the 700K, but those are the ones I was really interested in. So I'm going to go ahead and put this back together, fire it up, and see where we're at. So I've got it powered off, and I've noticed the zeroing on the meter is not perfect, so let's try to adjust that. And you're probably not going to get a good view of it with this camera angle, but we'll see what I can do here. Alright, that looks a bit better to me. See, there's still some charge in the capacitor when you switch it to plus DC, so I've been doing this on negative DC. The unit's off, by the way. Alright, I think that's a little bit better. So I'm going to go ahead and fire this up, and we will see how it looks. Okay, so I've got it set to 20 volts on the positive DC supply in the calibrated position. I've got the test mode off at the moment. Indication is still set to heater. I'll change that to plus DC after we switch it on. And we're going to check the 140 and 350 volt ranges since that's what we replaced resistors for. So I'll go ahead and flip test on. And yeah, I've got the fluke meter hooked up between the DC plus down here on the test panel and the cathode for ground. So on the 140 volt position, let's switch this over to plus DC. We're getting 20.3 on the fluke, and we are dead on 20 on the 140 volt scale right there, which is the second one up. So let's go to 50 volts. And we are just about perfect. And 100 volts. Also pretty much spot on. I'm really happy with that. And now let's switch into the 350 volt scale. Go back down to 20 on the supply. So the 350 volt being the top one, so it's reading right around 20. And 50 volts, we're right on 50, perfect. 100 volts, spot on. 200 volts, that's again perfect. And 300. And that's 296 on the fluke, and right about there on the meter, just below 300. So that's perfect. I'm really happy with that. And again, I didn't change the resistors in the other ranges. I'm probably going to keep an eye out for the 3.5 meg resistor, and for the 700 volt range, I can make that a little bit better. And we're just below 300, but I really never use this range, so I'm not so worried about that. I want to check the AC heater supply voltage now, since I changed the zeroing on the scale. So I've got it set to actually it's on 5 volts right now. So let's go over to heater, and let's get the fluke plugged into the heater and set to AC. So this heater reads out in percentage of the voltage selection. So 100 is what you want to adjust it to. So let's see what it reads on 100. Okay. So that's off. That's reading 5.7 when it's set to 5. So I'm going to need to look into the heater adjustment as well. Alright, so the heater was off a little bit, but that wasn't related to me zeroing the meter. Basically what they have you do is they have you connect your multimeter to the heater terminals. They have you set it to 6.3 volts, and then you adjust the variable knob until you read 6.3 volts on the meter. And that was actually off 100 a second ago. But basically all you got to do is you adjust this R350 here on the side until the meter lands on 100 when it's in the heater position. So that's 100% of 6.3 volts. And that's all there is to it. So you can, let's see our 12.6. This is 12.8. The manual says this has to be within plus or minus 5%, so you got a bit of wiggle room there. So anyways, yeah, I just want to do a quick check on that since I was messing around with the meter. But I'll probably end up going through and fully calibrating this thing next. It looks like I should have everything to do it except for some custom resistors that you need and some oddball values. So I'll probably cobble them together kind of like I did with the earlier fix. And I can also use like my resistor substitution box, although they do want some pretty high power ratings of a couple watts for some of those. So yeah, I might make a video on that. We'll see. Well, anyways, I hope you enjoyed the video. I'm sure anyone that owns one of these doesn't need this video to show them how to fix that problem, but maybe you'd like to take a look at the inside of the 570. And I'm definitely planning on having more videos featuring this as I learn more about it and tubes in general. I'm not a tube expert, so I've got a lot to learn, but I sent my TV7 tube tester off to Dan Nelson to get calibrated, and I'm probably going to be using this a bit more in the next couple of months while that's gone, and also my ICO 667, which I haven't really used much since getting the TV7. So, well, thanks for watching.